take it. Hey, I'm going to do a little video here on how basically how electric motors work and speakers and stuff like that. But we'll get to that stuff later, but we want to do the basics here. So if you take a look, I have a piece of aluminum foil. You'll notice aluminum, okay? I can't pick it up with my horseshoe magnet because whereas like this alligator clip I can pick up with my horseshoe magnet, the alligator clip is made out of steel, which is made out of iron, which has domains, which I can line up with my magnet. Where aluminum, okay, is made out of aluminum, and it does not have domains, so that if it doesn't have domains, I can't line them up. It's not going to be magnetized, okay? But the nice thing about aluminum is it's a very good conductor, so I can have charge go through it. So I'm going to have charge flowing through this, okay? I have my power supply, nice big beefy power supply. And I want to show you, if you think about this, I'm going to have a current carrying wire, and we already know that a current carrying wire has a magnetic field around it using our right hand rule. Now make sure when you're doing this, use your right hand. So using our right hand rule. So there's a magnetic field around this. Well, I have a horseshoe magnet. What's around that? Oh yeah, a magnetic field. There's going to be a magnetic field around it. So I'm going to get two magnetic fields. Well, if you get two magnetic fields, you're going to get an attraction or a repulsion, i.e. you're going to get a force. So anytime the two magnetic fields interact, you're going to get a force. And hey, look, I'm going to get a force. So let's talk about this. So just so you're aware, red wire right now is attached to the positive. The black wire, which is coming over here, is attached to the negative. So my current is flowing this way. So your thumb would be pointing this way if you're doing first right-hand rule. Okay, we're going to do second right-hand rule in a minute. But I have a horseshoe magnet here. Let me do this just so I can. Wow, what was that, folks? I don't know. Okay, that was. I don't know what that was. I'm in a room with. I think somebody is running away from the coronavirus. I'm not sure. But anyway, all right. So back to our video here. So I got my horseshoe magnet and here. And I want to show you if I increase the, just watch what happens as I increase the, okay, as I increase the voltage, increasing the current, it lifts up. So let's figure out what the force depends on. Well, the force is going to depend on the current, okay? Force is going to depend on, I don't have a different magnet here, but if I had a stronger magnet, then you would see that the force also depends on the B of that stronger magnet, which makes sense. But it also depends on the length of the wire in this field. So if you watch, you can definitely see if I have more wire in the field, I get a bigger force, okay? So force depends on B, depends on current, I, it depends on L. See if you can find that formula on the equation sheet. It's there. All right, so that's how you find the magnitude. We're going to pause and then we'll come back and we'll talk about how to find the direction. Bye, kids!